14 days of doom scrolling. That's all it takes. 2 weeks of lying in bed at midnight, thumb twitching through an endless conveyor belt of disasters, political meltdowns, outrage bait, and, inexplicably, a video of a golden retriever failing to catch a greep. 2 weeks of that, and your brain's ability to focus on a single task doesn't just dip, it begins to structurally unravel. You probably think you know where this is going. Yeah, screens are bad, blue light, put your phone in a drawer, drink water, I've heard it. Maybe you figure you'll feel a little foggy, a little sluggish. You'll just drink more coffee and power through. But here's what nobody tells you, and what the neuroscience actually shows. Your brain isn't passively watching that content scroll past. It's consuming it, metabolizing it. And just like eating nothing but sugar for 2 weeks doesn't just make you hyper, it quietly dismantles your body's ability to process real food. Doom scrolling doesn't just distract you temporarily, it rewires the actual machinery of attention, the hardware, not just the software. By day 14, the region of your brain responsible for sustained, deep focus is running on fumes. It's been chemically flooded, structurally stressed, and, this is the part that should make you put your phone down, it's beginning to show changes visible on a brain scan. Changes that, in other contexts, doctors associate with clinical attention disorders. Let's go through it, day by day, because this is happening to you right now, and you deserve to know exactly what it looks like from the inside.
Day 1. You pick up your phone after dinner. Just for a minute, you've had a long day. You deserve to decompress. The app opens. The algorithm, built and maintained by some of the most well-funded engineers on Earth, whose sole professional objective is to maximize the time your eyes stay on the screen, immediately serves you something mildly upsetting about interest rates, then something funny, then something that makes your blood pressure tick upward, then a dog wearing tiny boots. Your brain, at this moment, is having an absolutely wonderful time. Here's the biology. Every time you encounter something novel, something new, emotionally charged, or surprising, a small cluster of neurons deep in your midbrain releases dopamine. You've heard of dopamine. Most people think of it as the pleasure chemical, but that's not quite right. Dopamine isn't pleasure, it's anticipation of reward. It's the feeling that the next thing, the next swipe, the next post, the next headline might be even better than this one. It's the chemical of maybe. Under normal circumstances, dopamine is released for things that require effort and skill. You finish a difficult project, dopamine. You hit a personal best at the gym, dopamine. You finally understand a concept you've been wrestling with for days, dopamine. The effort and the reward are linked. That linkage is important. It's what drives you to do hard things. Scrolling surgically severs that link. You're receiving micro hits of dopamine every 3 to 5 seconds for the physical effort of moving one thumb approximately 4 millimeters. Your brain's reward circuit, the mesolimbic pathway stretching from the ventral tegmental area up to the nucleus accumbens, starts firing with the enthusiasm of a slot machine that pays out on every single pull. And critically, just like a slot machine, the payout never actually satisfies. It just makes you pull again. By day 3, this pattern is already embedding itself. You open your phone without making a conscious decision to do so. You reach for it during the ad break, in the queue at the supermarket, mid-conversation, just for a second, you promise. This isn't weakness. This is operant conditioning functioning exactly as designed. Your brain has already mapped phone to reward, and it is pursuing that reward with the same biological urgency it once reserved for food and shelter. And here's the cruel irony of the honeymoon phase. It feels fine. You feel entertained, stimulated, connected to the world. The disaster is happening invisibly, quietly, below the threshold of your awareness. This is still the fun part.
Day 5 to day 10. To understand what's happening inside your skull right now, I went through over 60 peer-reviewed studies from cognitive neuroscience journals, psychiatric imaging papers, and behavioral psychology research, so you don't have to read anything with the phrase dopaminergic modulation of prefrontal cortical connectivity in the title. You're welcome. Here's what those studies reveal. Your brain has a CEO. It lives in the very front of your skull, just behind your forehead, the prefrontal cortex. This region handles your most sophisticated cognitive functions: long-term planning, impulse control, the ability to sustain attention on a single demanding task, and crucially, the capacity to delay gratification. It is the neurological architecture of what we recognize as self-discipline, patience, and intellectual depth. It's what separates working through a difficult problem from just giving up. And it is exquisitely sensitive to disruptions in dopamine signaling. When your brain's reward circuitry receives a sustained flood of cheap, rapid-fire dopamine, precisely the kind that social media scrolling delivers, the prefrontal cortex initiates a compensatory response. It begins downregulating. It reduces its number of active dopamine receptors because the signal has become so overwhelming that the system is trying to protect itself from overload. Imagine turning down the sensitivity on a microphone that's been pointed at a speaker for 5 days straight. The volume decreases, but now you can't hear the quiet things anymore. The consequence of this downregulation is profound and practical. Activities that used to feel naturally engaging, reading a chapter of a book, working through a complex task at work, having a focused, unhurried conversation, begin to feel flat, gray, hard to initiate. Not because those activities have changed, but because your reward threshold has shifted upward. Normal life can no longer compete with the feed. This isn't just a theory. A 2019 study published in the Journal of Experimental Psychology found that participants who checked their phones at high frequency showed significantly impaired performance on sustained attention tasks compared to low-frequency users. And crucially, the impairment was measurable after just 1 week of heavy use. 1 week. The researchers described it as the brain entering a state of chronic partial attention, never fully disengaged from the hunt for new stimulation, even when attempting to focus elsewhere. Meanwhile, something else is happening in a different part of your brain. Your amygdala, the almond-shaped structure that processes emotional salience, particularly threat and fear, is being fed a relentless diet of negative content. This isn't accidental. Platforms have known for years through their own internal research that content triggering anger, anxiety, and moral outrage generates significantly more engagement than content that produces joy or contentment. Algorithmically, your feed will always skew dark because dark content keeps you scrolling. Your amygdala cannot tell the difference between a genuine immediate threat and a distressing headline about something happening 6,000 miles away. It responds to both the same way. So across days 5 through 10, your amygdala is in a state of near constant low-level activation, and your cortisol, your primary stress hormone, is quietly elevated for hours at a stretch, not spiking dramatically, just simmering chronically. This isn't just anxiety. A 2021 study from Stanford found that chronic low-level cortisol elevation directly impairs hippocampal function, your brain's center for new memory consolidation and new learning. Participants in the study who reported high social media use during stressful periods showed measurably reduced ability to retain new information, even when they felt subjectively fine. The damage was silent. They didn't know it was happening. Sound familiar? If you've ever wondered why you feel vaguely, inexplicably anxious, even on a perfectly ordinary day, like this video, because this is the precise biological mechanism producing that feeling.
Day 11 to day 14. This is where the subtle becomes undeniable. By day 11, your brain has adapted, not recovered, adapted to a world of relentless novelty.
The prefrontal cortex is operating at a reduced capacity. Its ability to exert top-down control over your attention, to say, we're doing this task now, stay here, has been worn down like a muscle that's been overstrained and undersupported simultaneously. Your default mode network, the system your brain activates when it's not focused on an external task, essentially your mind's idle state, where it consolidates memories and wanders creatively, has been hijacked. It no longer knows how to genuinely rest. It's been conditioned to scan, to anticipate the next input, to treat stillness not as restoration, but as absence of stimulation, which now feels uncomfortable, almost threatening. So when you sit down to actually do something, write, read, think, plan, create, something deeply frustrating happens. You open the document, you read the first line, your eyes reach the end of the sentence, and your hand is already reaching for your phone before your conscious mind has registered the impulse. You read the same paragraph 3 times and absorb nothing. You experience what researchers call task initiation failure, not because you're tired or unmotivated in any conventional sense, but because your brain's attentional system is now constitutionally oriented towards switching rather than sustaining. This isn't metaphor. A 2022 study from the University of California found that heavy social media users took an average of 23 minutes to fully re-engage with a complex cognitive task after an interruption, and that self-interruptions, where the user chose to check their device without any external prompt, occurred roughly every 3.5 minutes. The brain had learned to interrupt itself. It was generating its own distraction, hunting for the dopamine hit it had come to expect. But here is where the scan results come in, and this is the part where you should sit with the information for a moment. A landmark study published in JAMA Pediatrics in 2023, involving over 10,000 participants and high-resolution fMRI imaging, found that adolescents and young adults who engaged in habitual high-frequency screen-based scrolling showed measurably reduced gray matter density in the prefrontal cortex compared to matched controls. We are talking about structural brain differences, not functional quirk. Actual physical changes to the tissue of your brain's attention and impulse control center, changes that overlap significantly with the neuroimaging profile of ADHD. The brain, across just weeks of heavy use, had begun to physically reorganize itself around distraction. Your body is running hot at this stage. The chronically elevated cortisol is suppressing melatonin production, so your sleep is fragmented and shallow. Because your sleep is fragmented, your hippocampus cannot complete its nightly memory consolidation work, so your long-term retention is compromised. Because your retention is compromised, cognitive tasks feel harder, which makes the easy dopamine of scrolling more appealing by comparison, which drives more scrolling, which further elevates cortisol, which further disrupts sleep. It's a loop, a beautifully engineered, thoroughly profitable, biologically devastating loop. Before we look at whether any of this is reversible, hit subscribe because the answer is more nuanced than you want it to be, and the recovery protocol is as specific as the damage.
Here is the part you actually need to hear, and it is genuinely good news, with an asterisk. The brain is plastic. Neuroplasticity, the brain's ability to reorganize its own structure in response to behavior and experience, is the same mechanism that drove the damage, which means it can be directed toward recovery. Research from the University of Pennsylvania, published in 2018, found that participants who reduced social media use to 30 minutes per day for 3 weeks reported significant reductions in anxiety and depression, but more relevantly for our purposes, showed measurable improvement in sustained attention task performance. Not full recovery, but genuine, measurable improvement, beginning within 72 hours of reduced use.
A 2020 study in Computers and Human Behavior found that participants who underwent a 1-week social media detox and replaced scrolling time with monotasking activities, reading physical books, single-task writing, walking without headphones, demonstrated improved working memory scores and self-reported reductions in mind wandering by the end of the week. The prefrontal cortex, it turns out, responds well to being asked to do the things it was built for. But here is the asterisk. The lesson here is not simply use your phone less, as if this were a matter of individual willpower and personal virtue. The deeper and more uncomfortable truth is this. The same biological architecture that makes you capable of love, obsession, creativity, and intellectual awe, that mesolimbic dopamine system, is also the precise vulnerability that a multi-trillion-dollar attention economy has spent 2 decades studying, mapping, and engineering products to exploit. Your inability to focus is not a character flaw. It is a predictable outcome of exposure to a system that was specifically designed to produce it. The human brain is the most complex structure in the known universe. It took hundreds of millions of years of evolution to build. It was not designed to process 90 pieces of emotionally charged, algorithmically curated content per hour, every waking hour, indefinitely. But it will absolutely try, and in trying, it will reshape itself around the attempt.
That is what 14 days of doom scrolling does. The question is, what you're going to do with the next 14.